Hello, and welcome to our session. I'm Jean Haney, co-founder of Visual Integrity, and today I'll show you how to unlock PDF drawings and diagrams. Let's get started. As an Exchange format, there's nothing that even comes close to PDF. But, like with most things, there are trade-offs. When PDF pages are shared, their content is packaged tightly to ensure WYSIWYG display wherever the documents travel. The result? The reader sees exactly what the author intended, an authentic match. Oftentimes, the recipient needs to work with the contents of the PDF, but is unable to do so. Most simply look to the export features in Adobe Acrobat to transform the document into a format they can use. This works well for productivity formats like Word and Excel, as well as plain text and bitmapped images. However, drawings and diagrams, all vector graphics in fact, pose many challenges, which we'll explore together today. As mentioned, there are many ways to export rich text and bitmapped images from PDF files, but solutions for generating editable graphics are limited. This is what I and Visual Integrity are specialized in. Today, I'll share how to extract PDF graphics as editable drawings and diagrams, and to recognize the potential hazards in the process. Let's start off by looking at the export options in Acrobat. When expanding the export menu here, we're presented with a number of productivity and web formats. Notice the highlighted items. These are the only supported vector formats. Acrobat Reader, which is free, offers PowerPoint, but you need Acrobat Pro to export EPS and PostScript. Let's take a look at the export quality for these formats, starting with PDF to PowerPoint, where we'll start to see some of the pitfalls we'll dive into today. Acrobat's PDF to PowerPoint export delivers a reliable presentation structure with slides, outlines, notes, and color intact. Unfortunately, it's not as successful with the graphics. Look at three areas for comparison. The left is the original PDF, and the right is the exported PowerPoint slide. Let's take a look at the images. The original PDF had images for the logo and company name. These are lost in the PowerPoint output, where we just see placeholders for them. Next, let's look closely at object alignment. The Adobe PDF export does a good job with the lines and paths, but fails to align labels with their objects. Details like this matter. Finally, let's look at text alignment. Here we can see the export filter has not parsed date as a word, since there's too much space between the D and the A, and it crosses between lines. As a word, it's not editable, and the characters have been misplaced. In summary, the Adobe Acrobat PDF to PowerPoint export does a fine job with structure and slide outlines, but for graphics output it is unsatisfactory. Let's switch gears and look at the page formats, specifically PostScript and EPS, output by Adobe Acrobat Pro. This output is perfect. It's no wonder, since these are foundational Adobe formats. However, EPS is not widely supported in everyday office and technical applications, and not at all on the web. To edit EPS, you need pricey illustration programs like Adobe Illustrator and CorelDRAW. Since none of these exported Acrobat vector formats are practical for us, we need to depend on open source editors like Inkscape or PDF converters like PDF to Picture or PDF to CAD. The examples that we have reviewed so far underscore the challenge of extracting useful graphics from PDF. So, why are vector graphics locked in PDF? As we covered at the start, the primary goal of PDF is to be a WYSIWYG exchange format. We've seen with the PowerPoint example, it's very difficult to produce editable WYSIWYG graphics from PDF, and that was never the intention of it as an exchange format. However, reusing PDF graphics is a hot topic in many areas, including marketing, tech writing, engineering, and the supply chain. Contrary to popularly held belief, PDF editing is not taboo. It is of great benefit. If security is a concern, PDF can be password protected. There are many PDF document converters which produce reliable rich text, but convert graphics to bitmaps to ensure WYSIWYG. Today's session is for people who want to extract diagrams, charts, and drawings from PDF accurately and with all elements intact and in the right place. Let's look at why people want to unlock PDF graphics. Drawings travel across departments and between companies. They get new life when converted into editable vector formats. For example, By transforming a PDF-based CAD drawing into other formats, creating cost estimates is easier, sales and spec sheet design moves faster, and presentations are made more persuasive. Organizations are able to ensure compliance with company standards and branding guidelines, and they can leverage existing content which has been created by colleagues in other departments, shared with the supply chain and other stakeholders. No more wasted time redrawing or reinventing the wheel. Now let's look at a number of hazards to be aware of when converting PDF graphics into editable illustrations and publishing formats. During their travels, PDF-based CAD drawings are regularly transformed into publishing formats to create user guides and other documentation. PDFs of network diagrams and floor plans are converted into Visio formats like WMF, EMF, and SVG. Logos and other professionally designed graphics are converted to SVG for use on the web. Let's look at the 6 hazards you may encounter when converting PDF graphics for reuse. Let's start with fonts. This is probably the category where the most can go wrong, and the one which could easily be its own conference session. We know that using the perfect font can make or break the impact a document has. When that document is exchanged, we rely on a perfect match for our design. Each OS has their own set of standard fonts, and they rarely match up. The Big Four, Microsoft, Apple, Adobe, and Google, all have different standard font sets. To add to the mess, applications like LaTeX also have their own font sets, which are not available on PCs and Macs. If you have a PDF file which is not displaying accurately, it's likely that you don't have the same fonts on your system as the original author. Merck is a great example of a company who relies on technology to convert only the unknown fonts in a document to curves. This way, their equations and formulas appear exactly as intended, while searchable text is optimized. Fonts travel well when embedded in PDF documents. Due to licensing issues, not all fonts can be embedded in PDFs, and those that can are removed during conversion to other formats unless they are free open source fonts. Licensing issues prevent most fonts from stepping beyond the PDF document they are embedded in. Because of this, when you convert PDF to a graphics format, embedded fonts are substituted. Oftentimes, this is close enough to not matter. You can compare fonts in the document to your system fonts by opening up your PDF document properties on the left. Ones that do not say anything are likely not licensed and thus not embedded, but instead just referenced. If fonts that are not embedded are in your own font drop-down list, you will have a perfect match when you open the drawing. Otherwise, you'll see a substitute. In this example, you can see that font substitution compensates as well as possible for the mismatch, but the result depends on what fonts are licensed on your system. If you have something close, you may not even notice the difference. Here you see the original font in red. The PDF did not have embedded fonts, so when it was converted to Word, a very close font was substituted. The result is a very close match, as we can see by overlaying it in gold on top of the original red text. The more fancy or stylized a font, the more likely there won't be a suitable substitute. In this case, you should convert these fonts to curves, but we'll get to that in a bit. The next font trap is different font names. We've seen that the Big Four all have their own font sets. There is some overlap between them, but even when there is, the fonts may not have exactly the same names. There are a few variations of Arial, which itself is a version of the timeless standard Helvetica. When converting to a graphics format, the font names are included as referenced metadata. In this example, the Arial on the left is bold by default, while the Arial on the right sees bold as an attribute of the regular font. So you see, even when the font is identical, it cannot be found on another system because the name is different. This can be solved by mapping the two different names together, which basically redirects to the available font. In some cases, there's no room for even an iota of difference between the PDF and the converted graphic. When an exact match is paramount, we recommend converting unknown or specialty fonts to curves. This will guarantee a WYSIWYG match. For example, with Merck, it's the accuracy of formulas in their FDA submissions for a new medicine that are at stake, and for a company with a stylized font in their logo, it's their branding on the line. Let's take a close look at these two equations. The original is prepared with LaTeX, a favorite publishing system of scientists and scholars. The document was saved to PDF and looked great. When moving it to Word, to ensure no font mismatches, we convert it to Bezier curves. That's the top example. It's no longer editable, but it doesn't need to be. It needs to be precise. The bottom example is a straight conversion from PDF to Word with no font substitutions. You can see it didn't work out too well. This is a more lighthearted example showing what happens to stylized text when it's converted to PowerPoint on the PC and Mac. Windows can't match it, and the Mac has no idea what the font is. Decorative, stylized, and scripted text should always be converted to curves. Let's move on to kerning. Kerning is used to adjust the amount of space between characters to make words look appealing to the eye. It's usually reserved for headers and larger texts. A small kerning adjustment can make a big difference in how a word looks and the impact it has. When PDF is converted to graphics formats, kerning may be lost if your solution doesn't compensate automatically for it. All Office applications support kerning, so as long as you're aware of it, you can manually correct it using kerning for fonts in Office or the letter spacing attribute in SVG. Scanned pages are a big roadblock for graphics. Since scanned pages can be wrapped up as PDF files, it's important to understand the limitations of this type of PDF. Obviously, since they are bitmapped images, they can't contain any of the vector elements or metadata we need for them to be useful to us. At best, they can be converted into raster tracing layers or underlays for snapping and measurement. When a scanned PDF is converted into DWG, the native AutoCAD format, the result is an empty DWG object container with references to JPEG or TIFF images. Let's take a quick look at a CAD file, one version scanned and one vector, as they are zoomed to 1000%. As you can see, with a low-resolution scan of even this simple drawing, at 1000% it's impossible to tell what's what, which makes effective tracing difficult, no matter whether it's digital or manual. There are a few raster to vector solutions out there, but all have steep learning curves and require manual intervention and cleanup. Sometimes it's a better choice to just redraw from scratch, especially if the original is hand-drawn or low resolution. More often today, CAD systems are using TrueType fonts, which transfer as searchable text into the PDF format. This means that when the PDF is converted back to CAD or a publishing format, the text will be editable. However, drawings with SHX text or shape fonts are still pervasive in the CAD world. Each character is comprised of a number of pen strokes or paths. Sometimes, like with the letter Q here, a character can even contain more than one object, the O and the tail. OCR is effective on document text streams, but much less so on sparse text, especially in drawings where the text has no context. This is an area where much development is happening. When a PDF file is converted to a vector format, usually it's delivered as one consolidated object. In order to modify it, you need to ungroup it. Sometimes PDF files will also contain layers, but we'll get into that in a moment. Grouping is a technique that helps you organize compound objects or design elements. Groups can also be nested, meaning that when you open the converted PDF in PowerPoint, you may need to ungroup it multiple times to access a discrete element. In order to scale a number of elements together, they should be grouped in order to ensure proportionate and accurate results. Let's look at a quick example of ungrouping PDF content that has been converted to SVG. In this Dell brochure, as you can see, I need to ungroup the infographic a few times to get to the recycling symbol. Once there, I can select each object and change its color. In order to scale it, I would regroup it to ensure it grew proportionately. Being able to separate PDF files based on layers and to only work with selected layers is a powerful feature. Layers in PDF can be viewed according to the definitions in the PDF file or by the layers as defined by the author. This can be color, line weight, spot color names, or a combination. Layers can be merged into a single layer, or separate graphics can be created for each layer. An individual layer can be opened, and specified layers can be ignored. Let's open a PDF to view its layers. By turning selected layers off, we can visualize a clean, simplified drawing. When passing the PDF file through a converter, we can select these layers and ignore them. Here you can see that I'm turning off details like bricks, hatches, and other patterns to just focus on what I want to be able to edit in Visio when I move the file there. Here you can see that we have converted the full PDF file to SVG, choosing to remove layers with patterns and hatches which muddy up the drawing that we want to modify. The original is on top, and the one without patterns is below. Selective conversion has very powerful applications. If you take care to avoid the pitfalls we've reviewed, you'll find success converting your PDF drawings and diagrams to editable vector formats. Some tips: use common multi-platform fonts. Convert uncommon or stylized fonts to curves. Use selective layers to remove unnecessary objects. Remember to ungroup all nested objects. And if you have control over the source of the PDF documents, go back to the source of the scanned documents to see if you can get a computer-generated vector version. And for CAD drawings, encourage the use of TrueType fonts instead of shape fonts. To wrap up, let's look at some real-life examples of using PDF graphics in Visio, PowerPoint, and on the web as SVG. Let's start with Visio. Floor plans and network diagrams are regularly shared as PDF files. In order to reuse these graphics, the PDF must be converted to a vector format. Visio can digest WMF, EMF, SVG, DXF, and DWG. Of these, the best match is EMF, followed by WMF, both the native Microsoft Windows metafiles. It may go without saying, but you always want to get as close to the target application's native format as possible when converting PDF. CAD formats, DXF and DWG, should be avoided since they are usually very large files which don't map as well to Visio as the others mentioned. For this demo, we'll start by creating a blank drawing and choosing the Insert PDF add-on. Once the drawing opens, we can click anywhere and see that objects can be selected. Visio is all about shapes and connections. When the PDF is imported and ungrouped, objects like ellipses and rectangles are recognized and text is editable. Here, Visio sees the object we changed to orange as a rectangle and not just 4 individual paths. We can also grab just the relevant part of a drawing and create a new drawing to work with. For each app you work with, you'll want to find a PDF graphics converter that intelligently rebuilds the file and compensates for format differences to ensure you have a file that's not only accurate but easy to modify. Features like object recognition, PDF cropping, converting line objects to poly objects, kerning, recognizing dashed lines as lines and not individual dash segments. These are all important. For PowerPoint, we'll look at some additional conversion options that help when repurposing content for presentations. PowerPoint opens WMF, EMF, and SVG via add-ons or a separate converter. Just like with Visio, the best match is EMF, followed by WMF, since these are the native Microsoft vector formats. Inserting PDF graphics for reuse should not be confused with inserting a PDF object, which inserts a bitmap thumbnail of the PDF file as a reference and opens the full PDF when clicked. Adding PDF to PowerPoint in this way is not editable. In this quick demo, we'll take a look at reuse. First, open a PDF using conversion options that help avoid the pitfalls we've reviewed. Grab the logo from the cover and regroup it. Notice that it continues to look true to standard when scaling, which is essential. Now let's grab a graphic from page 32 and highlight a section. If these were bitmapped images, the quality would degrade the larger we make them. As you can see, we've changed the color for the individual donations, calling better attention to the importance of that group of supporters. Let's turn to vector graphics on the web. The widely supported standard is SVG. All modern browsers support it, and the viewer experience is superior to web image formats. Adoption is accelerating, primarily because SVG files are generally small and look great no matter whether they are displaying on a small phone screen or a jumbotron. Converting PDF to SVG is simple and works great. You can use an intermediate step like Inkscape, an open source drawing package. It's a specialized SVG editor which opens PDFs ready for modification. There are also standalone and batch converters for transforming PDF to SVG, with features to optimize display and handle some of the font traps we've talked about. In this demo, we'll look at how easily PDF graphics can be moved online. Let's open a PDF illustration directly in Inkscape and ungroup it. This is a pretty complex illustration, but everything moves perfectly from PDF to SVG. We can now make changes like coloring an eye lighter blue, or changing the color of his coat. Even fine details like coloring the pupil is simple. The tiger is not made up of random lines and curves, but poly objects and compound objects for easy modification. When we open the SVG in a browser like Edge, we can see by panning and zooming how superior SVG is to bitmaps online. And now we know how easy it is to create from PDF. I hope you found our session today useful and that you'll think of Visual Integrity if you need workflow solutions for converting PDF into vector or image formats. With almost 30 years of experience in PDF, our engine is robust and responsive. More importantly, it's been battle-tested by some of the world's most demanding companies: Oracle, Merck, BASF, Bosch, Swiss Life, and WebMD. We're proud to be previewing our new PDF Cloud Converter during OctoberPDFest. It's a free service which allows you to convert a couple of PDF drawings a day into editable vector formats. You can try it at convertpdf.today. We have software converters, add-ins for popular technical and publishing programs, and a comprehensive suite for technical writers and designers. Finally, our developers ecosystem is robust and reliable. It offers both SDKs and command line servers for creating, converting, and accessing PDF and object data. It's available for the cloud, as well as for Windows, Mac OS, and Linux. It converts PDF or PostScript. If any of this piques your interest, please contact us or visit our website to learn more. Thanks for your time today. I hope you enjoy the rest of OctoberPDFest online. And now, in the meantime, I'd be happy to take any questions that you have.
Thanks, Jean. All right, let's get some questions here if we can. As a reminder, you can still submit questions through the questions pane in your attendee control panel. So Jean, the first question I see here is, what's the right balance to strike between converting text to curves and optimizing searchable text? You're muted, Jean.
Okay, can you hear me now?
Yes.
Okay, sorry. I was muting on my microphone, but I also see there's one in the panel I have to hit. So that's a good question. In general, you want to maintain as much searchable text as possible in a document because you want that information available to be able to find it later. When something's converted to curves, there's no information about it anymore. So the only time you really want to convert to curves is when the accuracy or precision of that element is very important, like with the equations we used in the example. You wouldn't use it, for example, with accented text or something like that. You want that to remain searchable. So that's basically a balance you have to think about when you're saving the document.
Mm-hmm. So next question, would I tell if a PDF is scanned and therefore I would not be able to work with the graphics?
There's a couple of easy ways to do that. The first is what we call the blue test. It's just opening the PDF file up and clicking on it. And if the entire page turns blue, that means that that's a bitmapped image and it's probably a scanned drawing. Another one is to use the marquee zoom feature in Acrobat Reader and just select a small part of the drawing and zoom into it to see what it looks like. If it's sharp and clear, then it's a vector. If it's jagged or noisy or blurry, it's a scan. It's a bitmap.
Okay. Next question here is a little more technical. Does PDF 2.0 have more tools that facilitate handling of vector graphics?
I'm not sure that I understand that question exactly. So we, for example, our engine is able to grab all of the object data in a PDF file and manipulate it. So from that point of view, I'm not sure what the tools would be in PDF related to vector graphics, but we do have the capacity to access all of the object data in a PDF file and work with it.